Okay. Okay, so as I think it's Monty Python would say, and now for something completely different. Most of what I do, because I am not a research scientist or a software engineer, is coordinating between industry and the people who work at tech. Our staff are all over the map in terms of skills and abilities and PhDs and non-PhDs and things like that. But we could not do what we do. I couldn't do what I do with industry without them. So I thought I'd go through a little bit of why we even bother doing this, right? Most of the people here are from the labs or from universities, and you may not be on the front lines of working with industry, but there are some really good reasons for doing this, right? If your university needs to diversify their funding stream because, for example, maybe your state is bankrupt or you need more funds than you're getting or than you were getting from your state. If you are looking for new and interesting research projects, more public recognition, one of the things we love to do at TAC is do these research projects and then write stories about what we've done. For those of you who know, we want to do things where, like, NASA can talk about Tang, which is not the most wonderful orange drink in the world, but it was invented because NASA needed something that they could take and have their orange juice when they go up into space. So things like that. What are the things that have been developed at academic supercomputing centers that that we can talk about with industry, and that industry can say, we did this in collaboration with the center. Now, if you're in industry, it is to your benefit to work with academia because you don't have to buy the system. You don't have to pay the sysadmins, right? You get new ideas, you get fresh perspective, because when you come in and work with a place like TAC, you're also working with the hundreds of other PhDs and scientists who work at the University of Texas. And there's always something new and interesting going on. You get the support for your systems, code optimization, testing of new technologies, benchmarks, and you also get a lot of this workforce development and training, which is one of the things that TAC does a lot of. So how do you go about finding each other, right? For us, for TAC, there are a lot of companies out there, right? And I could go after the top 10 of the Fortune 500 if I wanted to, but I don't necessarily have sort of an in with them. What are our strengths? You have to look at what do we do well, and how do we sort of sell that to industry? How can what we do help solve their problems? So you start local, right? We're in Austin. We are 2.5 hours from Houston. The majority of my industry partners for my first 5 years were oil companies because that's who's here. They know that we have a lot of expertise and we have the systems that they want to try before they buy them. And that's who came to us in Ohio and at NCSA in Illinois. There's a lot of manufacturing, right? John Deere and Caterpillar and a lot of farm equipment and a lot of other manufacturing things are in the Midwest. In San Diego, a lot of their partners are from the entertainment industry. I could go after Hollywood companies, but they don't know me from Adam, and San Diego is in their backyard. So it works to your benefit to start looking at what's near you. One of the things that's been my goal at TAC is working with small companies and startups, right? I want to help the little companies get bigger. I know that we have the technology and we have the people that they may not be able to afford right away. And for a little, for some, what feels like spare change to some people, but is a lot of money for them. But for a small amount of money, they can come in and we'll work with them. The challenge is they need more help, right? The less experienced they are in the technology and high performance computing or data analytics or visualization, the more help they need. But that's sort of the way we go about it. There are challenges to adopting HPC that are sort of universal across industry, the national labs, the people who build the machines, the people who use the machines, academics. When I was at the Council on Competitiveness in 2005, we published the results of a study where there were 3 main challenges. One of them was, how do you spend $3 or $4 million on a supercomputer, and then you have to report that on your quarterly earnings. Now, that eventually when you start using this machine and you get faster time to market and better development and all of those things, that there will be benefit to having done this, but still doesn't matter if you have to take a $3 million hit on your balance sheet. Parallelized software and legacy codes, right? We were just moving into the era of blades and parallel software, parallel systems, and all these codes that couldn't run on more than one processor at a time. And where do you find the people who can do the things we need them to do to run the software on more than one node at a time? It turns out in 2016, the National Science Foundation funded NCSA in Illinois to do a similar survey of industry and academic partnerships. And the three main challenges that came out of that, I cracked up when I read this, is who can afford the big iron outside the government? Where do you get the money to pay for that? How do you modernize your code to run at scale? And how do you compete with startups when you're looking for your HPC workforce? So they're very similar. Things have not changed all that much, even though things have changed a great deal. So in the challenges of bridging this cultural gap, the most important best practice that they recommended to academics was take industry seriously, right? Companies do not get spring break, and they don't have time to wait for you to be ready or for all these other things to happen. You need to hire experienced people who understand business, so people with MBAs, right? I have value somewhere. My MBA has value. You assign people with the right expertise to work with the industry. You work with them on what are their problems and how do you help solve them, and make sure that the staff at the academic center understands that these partnerships are important to the center and they can't just blow them off. Not that they would, but that's a thing that we have to make sure that everybody understands what's going on both sides. And if you're interested, the link for the the PDF of the report is there. It's interesting. But I've given you most of what it's about. So how do we do this at TAC? Oops, go. We have about 185 people. We have about 70 PhDs out of that 185, and they are in everything. We have a lot of aerospace engineers, we have astronomers, we have bioinformatics people, we have chemists and physicists, we have an oceanographer, we have a little of everything. And we use all of their expertise to help all of our thousands of users from around the world. We have two big data centers. That big picture there is actually Stampede 2. It's not Frontera, which is the #1 academic system in the world, but we do a lot of training. And of course, we get the backing of the University of Texas. And one of the best things about that is that they pay our power bill, and we are very grateful. Current star partners, these are the sort of user companies that are currently part of our program. We have some large, some small, some local, some international. And then we have a handful of industry partners that have come in to work with us with their technologies. So we do a lot of in-kind contributions for things like this. But they will come to us and say, we have a problem. How do we do X, Y, and Z? And we'll help. So the University of Texas has a specific format for industry affiliates programs because a lot of different departments have them. Everybody pays the same fee. Everybody gets the same benefits. And most of it is on me. It's relationship building. It's making sure that they're getting handheld if they need it. They're getting information from us. We had phone calls with new partners or they would come to TAC for a day, and we sort of shop them around with different departments at TAC or different researchers for an hour here and an hour there and an hour somewhere else. We help them with recruiting. We supply either a space for an intern to come and work at TAC, or we supply them with resumes of the students that are taking our scientific computing programs so that they can get some kids to take internships there who already know how to program in parallel and what a supercomputer is for. We do, as I said, a lot of workshops, both large and small, and we'll give them a small allocation of hours for testing on any one of our systems so they can try and decide which system is best for their problem. If they want to do more, they want to get more closely embedded and do more research with us, we do a sponsored research agreement, something that everybody gets something out of, and that's where the intellectual property mess comes in, but that's usually, hopefully, pretty easy to figure out. But that gives them more direct access to our people, our resources, the data storage. We have large scale data storage, obviously, the software development, which is sort of why we're here today, and any other direct technology consulting or dedicated staff that they need. We give them webinars, so we talk about different topics. We've talked about how to build a green data center. We do a lot of our own system monitoring and instrumentation, so we want to share that, and we have open source software on GitHub that people can download and use to monitor their own systems if they're interested. We, as I said, do a lot of workforce development and training, and we've learned that you need to start early, right? We're not going to get any RSEs if we don't have any kids who know how to code. And so we have high school summer programs we call Code at TAC. We do multiple week or 2 week long high school programs for kids from underrepresented groups. We have credit courses at UT. We sponsor kids to go do the cluster challenge at supercomputing. And as I said, we have internships. And then we actually have professional internships, and we do lots of training in institutes to invite, and we invite all the companies to send people to these to learn more about how to do what we do and how they can do it better. So this is just one of them that was actually sponsored by BP last year, and it was sponsored by BP for last year, and we used the funds this year for virtual camp. So these are all actually pictures from 2019, I think. But we bring in all the kids and we send everybody a box with all the wires that they would need and sensors and a Raspberry Pi. And they get a keyboard, they learn how to code on the Raspberry Pi, they learn programming, they use Python, they use Jupyter notebooks, they do something with their sensors, they build little dioramas of what they use the sensor to find, and then they give presentations to their peers. And so they're doing peer research, they're doing group presentations, they're doing all these kinds of things that they will need to know how to do as they move forward. And these are kids who in many cases have never coded or programmed on a computer before, and they love it. So it's awesome. And our data has shown that a lot of the kids who come through our Code at Tech summer programs who weren't thinking about going to college end up going to college and start thinking about computer science. So we're doing something right. We're only doing it 30 kids at a time. So as I said, we teach classes at UT. So we have you can get an undergrad certificate, just like a minor in scientific computing from the University of Texas. And some of our classes are, software engineering, parallel programming for scientists and engineers, visualization, data analytics. We teach these as semester credit courses, and you need 5 of them to get your certificate. So our corporate partners have also supported our students in their cluster challenge, and we won 3 years in a row. Woo! Haven't won in a while, but we won 3 years in a row. And we've had partners who fund interns to come and work at TAC, and so they will pay. They'll give us a funding gift where we can pay the student to work at TAC during the fall and spring semesters, and during the summer they can go get a job with that partner and work there as an intern. So it works out pretty well for everybody. We also have professional software internships. I thought you guys would be interested in this. We're looking for people who are either doing a career change or they have an associate's degree or a bachelor's degree, and we accept people who just have lots of experience, messing around with a computer, taught themselves to code, anything like that. It is a professional 4-month internship. We do a cohort of anywhere from 3 to 5 people. They come in, they actually become parts of the teams that they're working on at TAC. They get to participate in code reviews, and you guys were talking about all the things we teach about how to develop software. This is where we teach them this. We start them very young, and sometimes we end up hiring them. One or two, I think honestly, 1 or 2 out of each cohort for the last 2 years we have hired, because this particular group, the Advanced Computing Interfaces group at TAC, has been growing by leaps and bounds. What we do is we build the web portals for all of the researchers that are running all of their stuff on the back end at TAC. So if you know what Cyverse is, or iPlant, or DesignSafe, all of those sites, and in fact, the Exceed front end site was actually also built by TAC. and our TAC user portal, all of those sites are built in this, and we have a process now for talking to the researchers and saying, okay, what do you need the site to be able to do? Because you get biologists who just want to, push a button and see a picture of their molecule. Well, that's great, but that takes a lot of work on the back end. And so we do the same thing. We embed our programmers with the disciplines to get them to get them help and to be able to produce a portal or front end for them to be able to work on it. We have lots of training. You guys are all welcome. It's free except for the institutes, and those are relatively inexpensive, and there's discounts for academics and for industry. And okay, so I will quickly go through, because I'm just about at time, some of the projects that our industry partners have sponsored. We had one partner come to us because they were using LAMPs, and their higher ups were very nervous about getting involved in the open source community. And so if they came through us, and of course we do everything open source, we could sort of hold their hand and say, it's really okay, right? Open source people are very nice. You can go in and we can help you make changes, and we'll upload them to the community so that the community can benefit from that. And if something new comes, we'll help you, install that as well. It was an interesting learning experience for both sides. We've just finished a project looking at training a deep learning system to identify offshore oil slicks from satellite pictures, because the company's trying to figure out if those are normal sort of seepage of what's under the ocean floor anyway, or if those are leaks from a pipeline, because it's important to know which is which, and you don't want to have to send a boat out every time you see those little spots on the water. We worked with another company on just their workflow and how they do things, getting from the software into the system and getting their results, and made suggestions for improvement to their workflow. We couldn't touch the software, but we could talk them through their workflow and figure out how to improve that. We've done some visualization software development where the company, they like these features from Visit and these features from ParaView, but how can we combine them and give them something that they want, that their people will use, that's better than their legacy version, which was worse than both of those pieces of software. So that was a fun one. And then we have a whole, as I think I said before, bio and life sciences group that has supported a whole bunch of different researchers, including some Nobel laureates, doing, either just helping them get their software parallelized, on more cores for the system, or in some cases rewriting the software in a different programming language to make sure that it would run better and properly and they could get the research they wanted. So a couple of things. I mentioned Cyverse. We created a software development kit with them so that you can leverage the Cyverse hardware resources, and it's in the Cyverse discovery environment. So this is for Cyverse is all about mapping the genomes of plants and animals. And it was created because the National Science Foundation had a lot of different organizations that were researching the same thing and not talking to each other. And so it was called iPlant in the beginning, but it's become Cyverse. And it means that they can all go to one site and share information and share databases and share software if they want to. And NSF is then funding multiple people to do the same research, and they can all build on what the others have done. We also are part of the drug discovery portal from UTMB, UT Medical Branch in Galveston, where this is a virtual drug discovery screening service. So you can choose a library and upload what you want to test, and within 24 hours, you get drug candidate hits from the drug discovery portal. So it's a cool thing. We're actually still looking for more funding to continue doing this. And then for some of the other industry partners that are not sort of medical related, this was a small startup company that moved to Austin and immediately came to see us and needed a system to do the training of the machine learning systems, where they had all the images, and they were funded by Homeland Security to use those images to help screeners find more of the weapons. I mean, when they did the testing, the fake weapons got through something like 70% of the time. 70% of the time. So I don't want to think about what that means about real weapons. But anyway, so can we make the TSA screening process more accurate so that less of that stuff gets through? So two of our partners, Technip and Shell, collaborated on the design of this 500-yard long boat that is now off the coast of Australia. They have to take, they used our supercomputers to model both the underwater landslides that could happen around the base of the little pipe, and also some of the motion of what the boat was going to have to do to be able to keep up if there was a storm or something. So it's a really interesting collaboration. The thing is immense and amazing. And what they do is they bring up the national gas, they bring up the natural gas, and it actually gets processed there on the boat instead of having to pipe it to shore and process it. So it's actually a step forward in that process. We have a rocket company, so Firefly, which is now funded by NASA and is going to be shooting rockets to take things to the space station. They started their rocket design when they moved to Austin, and that rocket firing facility is actually up in Leander, Texas, which is about 40 minutes north of where TAC is. So, and the other cool thing they've done is they funded a $1 million scholarship internship program at UT, where the aerospace engineers students get to design rockets. And if Firefly likes what the student has designed, they'll hire them for an internship. So it's a pretty cool deal. We've done some weather forecasting. We do a lot of weather forecasting. We did a simulation project funded by Raytheon looking at the weather around O'Hare. And this is from a couple of years ago, so it used 1,000 CPUs on one of our older systems, but it was a huge to do for them, and it was way more compute than they had, and it was a very large area to do the weather forecasting, and they were trying to get as detailed as they could around O'Hare. A couple more slides and I'm done. We did do for our industry partners sort of HPC for Dummies. We came in and it was like, what is HPC? Why should I use it? What is big data? How do I design the software? What are the different architectures? What's visualization? What do I need? What do I need to know? And some of them had absolutely zero experience in HPC, and they all came out of there sort of feeling much smarter about it all. And that's something that we could do again if we were asked. So additional programs every year when we have our annual meeting, we actually do a speed networking thing where we sit the partners down and we have students come in and do their little 2-minute elevator speeches and talk to the partners and then go from table to table and meet them all. And we did it over Remo. I don't know if you guys have used that online interaction thing yet in the virtual pandemic world, but it worked really well, and the students really liked it and the partners really liked it. So we're going to continue doing that. We provide guidance and testing for future system acquisitions. We've had another question of, hey, everybody's shifting to this other kind of networking. Should we do this? And what did you guys find when you did this? And shameless plug, because Nicole reminded me, this was actually, if you look at the date on that poster, this was the last in-person meeting that I went to and presented at in March of 2020, because everything shut down a week later. But we had a wonderful panel at the oil and gas meeting. We had another wonderful panel this year virtually. And we are going to do another one next year at the Rice Oil and Gas Energy meeting. And I hope all of y'all will come to that if you're interested. So I think I'm done. Oh, yes. We run at Texas scale. Who needs exascale when you can run at Texas scale? Bigger, faster, and more efficient computing, powerful user and application interfaces, and support for lots of diverse communities. So there we go. I'm done.
Great, thank you. And I mean, those are unbelievable projects.
That's a very small number.
Oh, I believe that. And it's still unbelievable. So we had a few questions in the chat.
Let's see. Yeah, and we would love to work with the national labs too, Reed. We're working with Los Alamos now. I've got an inquiry from Oak Ridge. We'd love to work with you guys. I think we work with India already.
I think so. Well, it's a big lab. I don't know everyone.
I know exactly. I think so.
I wonder if you work with our center. Good question.
He's going to figure it out. So the software internship program, Charles asked, is usually just, a lot of them are sort of just out of undergrad, right? They graduated, or they even got an associate's degree, or they're sort of career changers and they're not sure what they want to do, but they like coding or they like programming on their computers and they figure things out. And so it's a really interesting mix of people. And we absolutely are not wedded to, you must have a degree in CS and you must have a PhD and you must this, that, and anything. No, that's actually not what we want. We want people who come in and want to learn and want to work and get their feet wet. And we've had a couple people who didn't quite work out, and, no harm, no foul. We just say, thanks very much, but, you don't have to come to work next Monday. Oh. Right, exactly. The software developers can come from anywhere. I don't know if you guys know what the what the stream benchmark is, which is the thing that they use to benchmark all of the big supercomputers when they come out. But my husband wrote that 25 years ago, and he's an oceanographer. So he's got a PhD in oceanography, but he decided he liked the computing better, and that's what he does now. See, I stunned them all to silence, Blake.
I believe it. I'm gonna let them ask more questions, but I have a couple. I mean, I really support the reaching out to industry. Every university I've worked at is a land grant, so we're required to by ancient federal laws, to think about that sort of thing. But even here at UAB, it's a primarily medical school, but they have other kinds of research, and it's still pretty much a focus. And I'm curious to know, like, how do you start those conversations? Some of those companies you're working with are massive. I mean, global companies, and like, do you just like walk in their front door and say, hey, hi, I'm Melyssa?
I tried that. Okay. I tried that when I first started. I blind, emailed a whole bunch of different places, and I was like, hey, do you have problems that we can help you solve? And they just crickets, right? But as I said, if you look at who's around you, right? For us, like, I had one of the guys who retired already, but because I've had my program for 15 years, one of the guys from one of the oil companies was pretty much knocking down the door at TAC to partner with us before I had a program, right? I got very lucky because he came in and said, we want to work with you. You guys are going to do great things, and we want to support you. And they funded us having, the scientific computing curriculum and making it available for distribution. They're really, you get lucky when you get the right kind of industry person who, especially the ones who are sort of looking to the future. They know that they've got a bunch of people who are going to retire and they're going to need to backfill. And if they can't just hire somebody off the street, because they're not going to know how to program in parallel, they're not going to understand what MPI is and VAPIC and all of the, all those things that, and Linux and all those things that our guys have to know. So they pay us to train people. Unfortunately, some of the technology folks will just come to our staff and go, which is not my favorite thing, but we are training people up to be very good at what they do. And sometimes they're recognized by industry and they get stolen. And that's something we just have to live with.
Yeah,
I got very lucky. I think, but focusing on energy. And once you get in the door with one of them, they all know each other. Right. And the people I'm dealing with are not the CEOs and the CTOs of the companies, right? The people who come to my partner meetings are the guys running the supercomputers for those organizations, because they're the one, they know that they want to talk to us. And they have just enough budget to be able to pay their membership fee and come visit us. And one of the things that they pay for in their membership fee is the ability to just call up my chief engineer and go, hey, we ran into this problem, and I know you guys ran into it 6 months ago. What did you do? That's one of the things they're willing to pay for.
Yeah, that's interesting. I didn't realize that y'all had that kind of model. It's almost like a support contract, and in a way, maybe.
Sort of. Yeah. It's sort of in different way, but it depends, because part of what I do is build the relationship so that when they do want to do a research project in a different area, they know who to talk to, right? They have seen us be successful at all these other things, and they go, oh, well, we should talk to TAC about that. And then we get a research project together and we do something else, right? So it's not all about, sysadmins. It's about all the other things that we do as well. But that's the way in the door.
Yeah, could you expand a little bit more on like how you place people into industry? Because Vanessa and I and some other people have been talking about that recently, last couple of weeks. One of the things that we're always trying to do is to take students and get them into positions, right, and careers, and how do you bridge that? It always seems like that very first job as you come out of grad school or undergraduate, like that's the toughest jump, because you're just coming out of school and like,
yeah, because once you're in, right?
Yeah.
So I've got, we do that in multiple ways. One of them is when you have that relationship with a company and you say, well, are you looking for interns? Here we have all these classes. We teach these students how to program in parallel. We teach them about software engineering. Wouldn't you, like to hire some of them for your summer internships? And invariably that happens, right? But sometimes it's them sending me a job description and saying, hey, we have this position open, or here are our intern positions for the summer. Please share with your students, right? Now, and we have, Blackboard or whatever the software is that that the students use to do their courses online, and we can do that. We also ask them to share it with the university's, recruiting software, because they'll get a lot more, they won't necessarily get the HPC expertise. But for example, I had a company that's one of my former partners moved to a new company, and they do high frequency trading. And he said, we're looking for someone to come in and do all this sysadmin or programming or whatever. And I said, okay, I'll post it, but you need to go post it over here because you might get some finance people who have the computing skills who are interested. So, I don't have, UT is big enough that I don't, I get 150 students a semester. That's not enough for everybody who wants to get a job, right? Or who wants to offer a job. So I want to make sure that we notify all the other departments too. I don't want to be seen as like hogging all the good jobs. Like they would get really mad at me for that. So I want to get as many students out there doing things as possible, right? And it's all of those relationships have developed over time, right? I've been very lucky to find the people in those companies who are very forward thinking and want to fill their pipeline and are willing to fund things like a summer program for underrepresented minorities for high school students, because they know that unless you start them then or earlier, they won't end up in a place where we could hire them. I was asked to do a Women in HPC workshop at the Rice Oil and Gas meeting 4 years ago. And they basically said, you're going to keep doing this workshop until we don't have to do it anymore. Because the challenge of women in HPC and minorities in general in HPC, if you think ours is bad, women in oil and gas is abysmal, right? That is an old boys network, and it always has been. And fighting to get that changed and get the culture changed and get the people, to open their eyes to what the opportunities and the possibilities are, that's the uphill battle. And getting millennials to agree to, and Gen Z to go work for a company that's, polluting the earth, that's even harder. That's on them. That's not my job.
Yeah, and I've not thought about it before, but I guess that makes a lot of sense, that like having a tangible project as an intern or as a student, and then showing that to an employer and like being able to say, I don't just know something, I actually have solved a problem with knowing things is a very different thing. I'm hiring 6 interns right now too, and I'm going to change my strategy now. Having a conversation, and I appreciate that if nothing else.
Good.
I need them to have projects, and I need them to be, something that they can tout. I like that.
Yes, absolutely. You know, for the software interns, it's like they come out of it and they're like, look, I helped develop the software that runs this website. You know, I know how to write the code to make this, this, and this happen on the back end so that you can get this on the front end. Yeah, it's a real tangible result, if you want to call software tangible.
It's all data, I think. It's as tangible as
That's right.
anything else. Yeah. Yeah.
Visible.
Visibility.
Yes. Visibility. Yes. Well, there you go. See,
Right.
happy to set that up.
I mean, we're right next door to each other. I mean, relatively speaking.
LAMPS is one of the big codes on our
Yeah.
systems too. So yeah.
I worked down the hallway from like Steve Plimpton and Aiden Thompson and others, people who work on lamps.
Yeah, that project that we did on LAMPS was like 10 years ago. But
Oh,
happy
I
to,
see.
that's okay. I mean, happy to come back and do, you know, software development with anybody. It's what we do.
I have a lot more questions. I don't want to like take over the session though. So if anyone else has questions, please do chime in. But one of the things that I've struggled with, especially when it comes to software and, you know, cyber infrastructure support, is how do I even take industry money, right? And like what rates do I charge them, and how do I calculate that? And like how do we create, you know, business plans, I guess, right? And because I don't have that background, and clearly you do, or something approaching it.
Well, so part of it is for us, like the University of Texas has a business services unit.
Okay.
And so they set the price. I don't get to pick the price of what I charge for my cycles and storage and VMware, right? They, not VMware, VMs. We submit a spreadsheet that I feel bad for my finance officer when she has to fill it out because it is ridiculous. How much did you pay for the system? How many people are getting paid to work on it? What's the software? What's the power bill? Blah, 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 blah. And they come back and say, okay, you are allowed to charge this much, this much, this much, right? And we have different rates for industry, academia, and internal users. But they decide, and I am not allowed to be competitive with Amazon or Google or anybody else's on-demand services, right? My price is actually supposed to be more than theirs
Right.
intentionally.
Yeah, I think that's a federal law, right? You can't
Right.
subsidize, you can't use federal funds to subsidize something to compete against it.
Right.
Yeah.
I can't compete against industry. We lose our 501c3 status. The university would be very pissed at me if we did that. So, so, well, and hopefully they get more for the money, right? They get more direct interaction with us. They get more sort of picking the brains of all the people at TAC. It's a really good, it's really good relationship for us because I'm not allowed to make money anyway. I'm allowed to do cost recovery, you know, and we have special permission from the National Science Foundation on the systems that they fund, where we can use a small percentage of it to do industry collaboration. And when we come up with a cool picture or a cool result from one of our industry collaborations, they will show that in their presentations. So that gets all of us more good press.
Is there any quick question for you?
Speak.
First off, great presentation. Question that I have is, I like the point about academics taking industry seriously, because that's not something I'm very adept at myself. You know, are there any like resources out there for that kind of thing? Like it's like a pep talk I never got that pep talk from my PhD advisor.
I think that's, you know, that's part of it. A lot of the people at TAC have never worked in industry, right? They came out of school, they started working at TAC, or they started working at another university and they came to TAC. And so you're still in academic mode. And it sometimes takes a lot of cajoling and reminding and pushing, but it's like, look, you know, this is helping to fund, you know, your work, right? You get to do what you do because industry is paying for you to do this, and you need to actually do it, right? But there is not that I know of a resource or a pep. I mean, I can come and give a pep talk if you want, Reed, but
Yeah.
I was going to add a point. So I do know a lot of collaborations go on at my lab. I can't speak to them because I don't know how they work, but at Stanford, at least, I remember like getting these collaborations between industry and like Stanford or research computing where I was just like really important to me. And I would say I had about 8 different efforts to do that. And out of the 8, out of the 8, 1 was successful. It took 9 months to get the contract done. And honestly, the price that Stanford had to charge based on what came from like the financial department, I thought was ludicrous. It was like 1.5 times my salary plus some overhead. And the only reason the tech company could afford it was because they're a big tech company and that sort of thing. But it was a huge, and then the other one, there's one more that almost worked out, but we never could get through the paperwork. And the other ones were just total failures because as soon as I said, yeah, I can help you with that, but here's like sort of the funding model that Stanford uses, it was a hard no. It was like, oh yeah, sorry, yeah, that's just too much. And it didn't feel at the time like something I was empowered to change because I can't go and like change the funding. Like the university is so focused on this model that they have to, I don't know where the money goes, but it felt like they wanted to make money in exchange to make it worth it. But in doing that, they prevented all collaborations like that from happening. And so the typical collaboration that happened was typically through like, traditional grant between like researchers. And then by way of that grant, research computing would receive money. And the other thing, which I'll harp on about here, is that we in research computing were unable to write our own grants. We could not apply for anything to get money because no one, even the director of our group, could not do that. She was considered staff. She was not a PI. I had a PhD. I couldn't do it. Several people in my group had PhDs. No one could do it. And it was totally the example of being between a rock and a hard place and people would wonder why we couldn't, hire more people or that sort of thing.
So a couple things. One, Stanford is famous for having one of the highest indirect cost rates. And so what happens is, right, we figure out how much it costs to have this person do a research, and it has to be a research project, right? There's the person cost, there's the fringe, which is, keeping the lights on and giving you a desk and all the things that university pays for. And then there's indirect cost, right? Indirect cost for us is somewhere over 50-something%, right? So it's 1.5 times, it's going to be 50% more than whatever you're going to charge them anyway. And 25% for fringe. So there's all of this extra tack on. Stanford is famous, for 1.5 times, for their indirect is ridiculous. And it's supposedly not that the university is making money. And the bonus, university finances, which are a ridiculous thing, right? Whatever TAC takes in an indirect, whatever the university takes in an indirect from TAC last year, they have to give us in our budget next year. So it actually does, we do get a little bit of funding for that back for it. But it is just to cover like keeping the lights on and paying people and paying for health insurance and all that stuff. It's just that different universities charge different rates. And the paperwork, so there's 2 different levels of paperwork, right? There's multiple levels of paperwork. For my industry partners, they sign what is, I have termed, the most vanilla agreement the University of Texas has, right? It says, we're going to play nice in the sandbox. There's no intellectual property being traded here. You're giving us what basically amounts to a gift, and we're going to chat and share information and, all that. That's basically it. And I still get pushback from lawyers about what it says. And it's like, no. It's just that we're going to play nice in the sandbox, sign this piece of paper. And mostly they do. The research agreement, which is already 20 pages long before you fill in anything, is the one that has all the intellectual property and all of the other stuff that the lawyers are always going to worry about. And that one is where we start charging the indirect cost and the per person cost and everything else. But, we get those, it depends on how important that project is to the company, whether they're willing to spend that kind of money, Topiers. No, the sports program.
Money. You have to water them and trim them.
They do. The sports program at UT brings in enough of its own money. Thank you. Have you seen that Longhorn logo everywhere? Mm-hmm. Yeah. Anyway. So V, I completely feel your pain. I understand. More questions, Blake?
I'm a scientist. I always have more questions. I always have more
Okay.
questions. You know, it's job
Okay.
security, right? But it is getting a little on towards the day, and I don't want to take up. But maybe the thing that I am absolutely most interested in is, Tim. We work with Tim a lot because he actually lives in our backyard, and I happen to know that. I work with Drew a lot at Texas A&M. I know Dan and Matt through Cyverse and others.
Yep.
So I'm wondering, again, this is sort of the question I had for Reed. As a community member who is reliant on a lot of things that come out of TAC or are at TAC, like, what are things that I can give back? Is there anything that I can help out with? Like, I feel like I take a lot from TAC, but I don't know if I ever give back anything, to any of these things.
I mean, that's what we're here for, right? That's what we do. We love to have partners on things, right? We go in for, God knows, we go in for these giant NSF grants or even the small NSF grants, right? If there's something where, let's say there's a piece of software, like lamps or something else, where there's a piece of software where you have someone who's an expert in this, and we have someone who's an expert in this, and they want to do development together, we go in for a lot of those little NSF grants all the time, right? Matt has a bunch of them, but also all the bio and life sciences people who work for Matt each have a couple of grants of their own, whether they're from NSF or NIH or DOE or foundations, right? There are places to go to get funding to work together, and you come out with something better for everybody. We love to do that, right? Part of our problem is we have a couple of groups like the life sciences group and the AI and machine learning group, where we literally need to clone the people in those groups because there is so much demand for what they're doing and we don't have enough people. We would love to do more.
That might be a conversation I should come around and have at some point or another. But a pointed question. I was really impressed that y'all had a lot of medical research, but I didn't realize there was any HIPAA or FI or FERPA compliance.
All of our systems are, the big systems, Frontera and Stampede 2, are HIPAA, FERPA, FISA, like whatever, all of the, we can't do trade secrets, and we can't do like secret information. Yeah, top secret information, but everything up to that, right? And now we have a medical school, the Dell Medical School, which just graduated its first class last year, I think. What a time to graduate from medical school. They were the first new medical school formed in the United States in like 50 years. And one of the things we did was we put computational thinking into the medical school immediately from the ground up, so that one of our staff is now half-time to the Dell Medical School and working on women's health issues and collecting data over there and doing visualizations and all kinds of amazing things. So they're looking at maternal mortality rates and using an app to track women as they're pregnant, and are they don't have to log in or anything. It's not, the camera's not running, but do they pick up their phone? Do pregnant women like pick up their phone and surf at 3 a.m? And is that good for their pregnancy? Is that good for the health of their baby? And how does that, and so we've only had 1 year of collecting data, but how does that change how the baby's doing after a year? And it's an amazing research project, but we're working directly with them, and having them here means that our bio and life sciences projects have just exploded.
Andy has a question in the chat.
IP generated in a commercial contract. So university has a tech transfer office. They also have an incubator for small companies, but in general, the research contract says, usually it's fixed price. We have figured out that it's going to cost this much for us to work with you. And if we develop something that, so starts with, if you bring in something to work with us and we don't touch it and you take it away again, the IP is yours. As soon as someone from our organization touches it, helps you with your software, touches the code, fixes something, fixes a bug, does the parallelizing, then we jointly own it. and you get a non-exclusive royalty-free license. You get first dibs on licensing whatever it is that we now own together, that we did together. It took me a long time to learn how all of that works, but that's how it works. And in terms of intellectual property, the UT lawyers have gotten better over time at, what's the best way to say this, not cutting off our nose to spite our face, right? To say, no, we're going to own this. And the company goes, well, fine, I don't want to work with you. And we have to be able to say, wait, we don't need to own that, but we want to work with them because this other thing is going to come out of it. And they've gotten a lot more willing over the years to negotiate different ways, different outcomes for things like that. Yeah. Andy, do you know my friend Sharon Bertagiva?
Did you say Gava?
Yes, Sharon. Do you know Sharon?
Not personally, but I was a graduate
okay.
student in the same department as her husband.
Oh, okay.
I think so.
Yeah.
So
I know somebody at almost every one of these institutions, so
it all comes back around.
it all does. We all know each other. Well, I've babbled at you guys for more than half an hour, so you know.
Oh, we're at the hour mark, actually. So this is wonderful.
Oh my God.
It's been,
Oh my God.
and this is a great way to end. This is, I really appreciate having this insight. And this is, I know that this is a missing piece of my program, and I would imagine it's a missing piece of many programs, as you were saying. So thank you. I really appreciate the insight, and now I have a face and a name and a title and things. So
And you have my email address, so you can find me.
Fantastic.